All right. Well, thank you everyone for coming back for this this next iteration. As you see all these slides, there's going to be some links in the slides. You can go to the website to download the Markdown. So I want to do a really quick flash poll because I don't think anyone else has done one. What is the area of focus for most of the people here? Can I have a show of hands if there are iOS developers here? Okay, all right. How about macOS? And you can raise your hand, okay, a little less. How about server driven? Okay, a lot. Embedded? All right. Any Windows? All right, a few. WebAssembly? Yeah, a few. And anyone Android? All right, yeah, we got a few. A pretty good showing. Okay, that's just this sort of level set. All right, so I think everyone knows what Android is. Android is an operating system. It's actually the most widely installed operating system in the world by a large margin, not only on consumer devices, but also embedded systems, cars, IoT devices. It's based on the Linux kernel. Its foundation is the Android open source project, which is an Apache licensed project, and then almost all distributions, almost all Android certified devices run with a proprietary layer on top of it. That's the Android mobile services and the Google Play Store and things like that. Often when I'm talking to iOS developers and Android developers, I find there's a huge cultural gulf between them. Everyone sort of thinks that the others are very alien, completely, unknown country to each other. But Android development and iOS development are really parallel universes. Every single aspect of iOS development has a peer in Android. Android on iOS, the modern language is Swift, which is the next iteration of Objective-C. On Android, the modern development language is Kotlin, which is the next iteration of sort of Java. They both have their own build systems that are written in their own languages. Swift PM is obviously written in Swift, and Gradle, you build your Gradle files using Kotlin. The platform SDK, the mechanism by which you communicate with the platform, is on iOS is mostly Objective-C, but with a little bit of C and a growing amount of Swift. On Android, it's almost exclusively Java, and there's a little bit of C and something called the Native Development Toolkit. And then sort of at a higher level, in general, when you develop for Android on iOS, you usually use Xcode. And for Android, you typically use Android Studio, which is JetBrains' product. Local development, you have an iOS simulator. On Android, you have what's called the Android emulator. More or less the same thing. And then going even higher level to actually build apps, the modern mechanism to build apps on iOS is SwiftUI, and on Android is something called Jetpack Compose. They're both very much similar concepts. They're declarative user interface languages, the next iteration beyond their previous more imperative things. To package an app, you zip them up with their code and their resources, you sign them. On iOS, you call it an IPA. On Android, you call it an APK. And then typically you'll want to distribute these to a store. On Apple, you go to the Apple App Store Connect. For the Google Play Store, you go to the Google Play Console, and then you have the marketplaces you can distribute to. So every single line item in iOS development has a peer for Android. Now, for Swift on Android, people have been working on this for 10 years, over 10 years, since even before Swift was open sourced. Way back in October of 2015, Romain Goyette experimented with cobbling together a mechanism for getting Swift to build against the Android NDK and getting something running on Android, a hello world, and he succeeded. He wrote it up. It's a very interesting article if you want to sort of look at the archaeology of how this stuff works. And then the next year, we had the very first Swift application, at least partly Swift application, available on the Google Play Store. That was Jordy J, one of the early contributors to this project. And then people have been sort of iterating on this for many, many years. But it wasn't until last year that Johannes called me up one day and said, look, we need to really get together. It's been sort of fractured. Everyone's sort of doing it half as a hobby project, half as, their own little bespoke parochial project just for their own product. We really need to all form a unified effort. So we got together and we formed the Swift Android community workgroup. And the goal with that is to come up with one single Swift SDK for Android that people can use for building applications. And that very quickly gained traction to the point where just a few months later, the Android workgroup was officially announced. And that's where we're at now. There's an official Android workgroup. Over the years, there's been a number of people whose names, whose handles you might recognize, who have been really the heroes of this project. The first three on this list, Andy Drook from Riedel, CompNerd from the browser company, and Finnegalfen, have really been sort of doing massive amounts of effort. Those first three are currently on the Android workgroup. And then some other people over the years have contributed huge amounts to getting this project going. It's really been a very grassroots community effort. People have been coming into it sort of from their own passions in order to promote this on Android, because Android is really the final frontier for Swift, right? It's got a presence on all the consumer platforms, obviously iOS and macOS, but also on Linux, on Windows, and then on web, you know, the sixth platform. But Android has thus far really been missing, and we really needed this to complete the sort of picture of Swift on there. We've talked in past talks today about cross-compilation SDKs, so I don't think I need to really give a whole lot of background about it. But the Swift SDK for Android is implemented as one of these cross-compilation SDKs. And it's cross-compilation SDK because you compile something on a host platform for a completely different target platform. If you've developed iOS applications, you're doing that all the time because iOS is a whole different operating system than your host platform. One difference between the Swift SDK for Android and the other SDKs is that Swift SDK for Android actually has three parts. It has a host toolchain, which is the open source toolchain that you need to install to run Swift C. It has the SDK for Android, which contains all of the pre-built modules that you deploy onto Android. It also includes the Android Native Development Toolkit, the NDK. And that actually has the cross-compilers that Google distributes in order to compile these the code down into something that's going to be able to run on Android. All the information about sort of getting up and running with the installation is available on the Getting Started guide, which is linked to from the slides at the bottom of this slide. But yeah, so the three main parts I just went over. You've got the host toolchain that again you need to install it from the open source version, not the Xcode one. You got the Swift SDK for Android, which you install using Swift SDK install, and then you have the NDK, which you can get in a variety of mechanisms. If you say install Android Studio, you'll get that as a side effect, or you can just download and install the Google SDK directly, and then you'll get it from there. And then on top of that, in order to actually test things on your device, you'll want to get the Android emulator up and running. In general, when you want to build a package for Swift, you run Swift build with the Swift SDK command, and then you pass in the right triple. And then Android has a number of different architectures that it supports. The Swift SDK for Android supports 64-bit ARM, 32-bit ARM, and that's not uncommon in sort of older devices that are still floating around. And then x86 64, which isn't really something that you ever find on a handset, but is in Chromebooks. And also, if you are developing on an x86 computer, you'll be using an x86 emulator. So just for your own development, you have that. They also support 32-bit x86. That's mostly unheard of these days, so we didn't really bother with it for the Swift SDK for Android. And then there's some deprecated and removed other architectures. But the point of this is that the Android architectures kind of come and go, and one of the challenges with the work group that we're going to keep up with is that if they ever say resurrect RISC-V support, then we're going to keep up on that. So what do you get with the Swift SDK for Android? You get pretty much everything you get for Linux. So you have Foundation, you have Dispatch, you have the Swift standard library, of course. You have observation, and you have testing and XCTest. And then you have an Android module. And the Android module is kind of a superset of the equivalent of libc on Android. So if you ever need to use fopen, if you're ever importing Darwin on your iOS or your macOS, you'll be importing Android on Android. And then on top of that, that has some interfaces to the Android low-level NDK. What don't you have? Pretty much everything else. Core graphics, core location, CloudKit, StoreKit. Basically, if it starts with the core or it ends with the kit, it's not there. UIKit, Swift UIKit, that's not there out of the box. And so that sort of is to set your expectations for what you're going to be able to do right away with it. If sometimes people come to me and they say, oh, I've got this SpriteKit iOS app, I want to get it running on Android. That's great. Have fun porting SpriteKit to Android, because you'll need to port all the lower level frameworks as well. But what you don't get out of the box, you can get through external packages. I'm sure many of you are familiar with the Swift package index. Last year, they started including Android in their build matrix using a preview of the Swift SDK for Android. And almost immediately, almost 30% of the packages compiled right away. That's thousands of packages, which is really heartening because it means that you have a lot of popular packages you can immediately depend on that are just going to start working on Android. If you have your own packages, or you have a package you're interested in that you'd like to see working on Android and isn't, porting them is actually a fairly straightforward mechanism. The general path to porting to Android is that, say you have an iOS package, if you can get it working on macOS, then you're kind of a third of the way there. And then if you can get it working on Linux, then you're 2/3 of the way there, or I'd say even 90% of the way there. And then basically you can try building on Android, and the changes you need to make might be fairly minimal. I mentioned on the previous slide, I've written a porting guide that you can look at that link that has a number of sort of the finer grained details. But generally speaking, this is what you need to do. If you're ever importing glibc for Linux, or you're ever importing Darwin directly, you usually don't because you get that for free from Foundation, you would be importing the Android module. And then the other thing to bear in mind that Linux people, I'm sure, already know about is that Foundation on non-Darwin platforms is split into multiple submodules. So, for example, if you just import Foundation, you're not going to be able to use URL session out of the box. You need to import Foundation networking. And you need to conditionally do it, because if you don't do that, then it won't compile for Darwin. So it's just one of the little things. But I would say I've submitted PRs to various popular projects that that needed Android support, and I'd say this covers like 80% of the work that you need to do. It's actually not that hard a project. So how do you build and run a package for Android? I can do a really quick demo. So pay no attention to, I'm just going to copy and paste some stuff. So you make a new project. We can make a new little executable called demo command. You can run it locally. Just build and run it. This is just running on the Mac, and then it runs hello world, because that's all that the default package does. And then once you have the Android SDK installed, you can swiftly run Swift build, or you can just run Swift build if the right toolchain is in your path. And then you pass it the triple to Android. In this case, I'm on a M1 ARM Mac, so I'm running against ARM 64. And then here we are also saying just compile it down into a single executable. And then you see from these two compilations that we did, the macOS one is a Mako 64-bit executable that runs on your own host. And then the Android build is an ELF, which is the Linux's executable format. And you can look at the sizes, and the size is not bad. It's 8.4 megabytes, not quite the 81K, because this is bundling in the whole Swift standard library. It's a single standalone executable. And then to actually run it and test it, we need to actually have an emulator installed and running. So there's a bunch of different ways of running the emulator. If you had Android Studio, you could open a little graphical user interface. The Skip tool that I work on does a lot of stuff. It's a complete package for building entire applications, but also has a lot of sort of Swiss Army knife utilities, one of which is you can run the emulator, you can run test cases and things like that. So that's a really easy way to just launch the emulator. And then once you've got your built project, you can run ADB push. ADB is the Android debug bridge. And we're just copying that demo command up to the emulator. And then there's one little wart here. You also need to copy up libc++ shared.so. It's something we're thinking about making a little clearer. And then you call ADB shell. You can just go log into Android like it was any other host, and then run the demo command. And you've got Hello World coming up on your Android device. So what else can you do? You can do testing. You can run test cases on your device. That's a little trickier because there's not really an existing front end for it. So in Skip, so say we build create a new demo lib project, build it, and then run local tests. That'll run sort of the standard Swift testing tests. Skip also has a front end to running tests, and that actually builds it as the XC test executable, copies it in named dependencies up over to the Android emulator, and then runs through your test cases. This is really critical if you're trying to bring your own package to Android, because it's how you're going to be exercising this. But in addition, we have some continuous integration options. There's a Swift Android action available that if you want to start adding this to your testing matrix, say you have a package you are already running and building on Mac OS, iOS, Linux, you can also just tack on Android testing right there. And that's a great way to, once you've gotten it running, keeping it running, keeping it on that matrix. And I've also contributed that up to the GitHub, similar action up to the Swiftlang GitHub workflows. So we're in the process of getting GitHub Actions working for a lot of these, a lot of the Swiftlang and Apple packages like Swift Collections and things like that. So to wrap it up, the current status of Swift on Android is that it's available as in the 6.3 in the main branch, nightly snapshots. You can go to swift.org to the install page, go to the very bottom. You'll see the Swift SDKs there with the link to the Getting Started guide. It's on track to be part of the Swift 6.3 release, which should be happening in spring. Some of the works in progress right now are debugging support. The debugging support is quite weak. Gabrielle has been working heroically on that. Testing improvements, I've been working on that. We want to be able to actually test as an application, not as just a command line tool. But there's a lot of stuff that needs to be done, needs to be worked on. Thinking about packaging, how are these things going to be packaged into application bundles, size reduction. Right now, if you're including full foundation, you wind up with pretty big binaries. There are a lot of things that we really need to start looking into. So we're definitely looking for volunteers, contributors. Workgroup meets every couple of weeks, so we'd love to have people popping in, thinking about things that they might be able to help with. And then the next thing that I need to mention is, you saw test cases, you saw a command line tool. Those aren't an app, right? You're usually probably interested in Swift on Android because you want to build an app. You don't want to just build like a hello world. And that opens up a whole world of integration. How are these things to be bundled into these APKs? And how is it going to talk to the native SDK for Android, which is all in Java? And that is Mads coming up next, who's going to talk a little bit about the work that the Swift Java group has been doing alongside the Swift Android group in getting Java communication working back and forth. So try it out. Look at the platform. We often post things that are interesting in there. Get your packages working on Android, and that's it for me. I'm going to be around here, and also at FOSDEM, I'm going to be hanging around at the F-Droid kiosk a lot, which is in Building U, Entrance D, Level 1. So come by and chat with us about Android stuff. And again, you can get the slides from skip.dev/talks FOSDEM 2026. All right. Thank you all very much.